In this video, we're taking a look at 3.3, planning a field trip. So let's understand the problem before we get into trying to answer any of these questions. So science teachers at Everett Middle School want to take their 8th graders on a field trip to a nature center. It costs $750 to rent the center facilities. That's very important. The school budget does not provide funds to rent the nature center, so students must pay a fee. So students are going to have to pay a fee. Now, the trip will cost $3 per person if all 250 go. The teachers know, however, that it's unlikely that all students will go. They want to find a way. Right here is what we're trying to do. They want to find a way to find the cost per student for any number of students, right? So we're going to try to come up with an equation that relates the cost per student to how many students are going. Because if we think about the one known, our constant, the constant is it's going to cost $750 whether one student goes or all 250 students go. And we're going to look into the relationship between the number of students and the cost that the teacher should expect per student. So how can that relationship be expressed in an equation in a graph? We're going to look at trying to answer that question as well. So let's go ahead and get started. Go ahead and copy and complete this table in your notes. All right, so copy and complete this table. You have the number of students and then the cost per student in dollars. If there's 25 students that go and you know the total cost is $750, you have to figure out what is the cost per student. So go ahead and copy this table, complete both rows of that table, and then come back to the video to check your answers. All right, so if we look at our numbers, when there's 25 students going, it costs $30. When there's 50 students that go, that halves the cost for all of the students. So if 50 students go, then each student pays $15 and so forth. So go ahead and check all of your costs per students there. And then go ahead and answer 2, 3, and 4. Now that we all have the same table, the same data, answer number 2, 3, and 4. Okay, taking a look at number 2, it says describe the pattern relating the cost per student to the number of students, so the cost per student to the number of students who visit the nature center. All right, so we're trying to come up with an equation to relate those. So if we think about the cost per student, looking down here, it says the cost per student, as the cost per student increases, right, as it increases, so right here, it's increasing, the number of students. As the number of students, right here, as the number of students increase, the cost of students actually from left to right, you notice that it decreases. So the cost per student decreases. Okay. Now on part 3, they wanted you to write an equation relating the cost per student C to the number of students N. So those are our variables. Remember, you have C, N, and then 750 was our constant. So that total cost was 750, regardless of how many went. Right, and it's the number of students, so it's going to be the number of students times the cost per student. That needs to multiply to give you $750. Okay, so that's one equation you could have. If you wanted to get the cost per student by itself, then you would take 750 divided by the number of students. And this, if you did this table correctly, is what you did up here. For example, at 150, there are 150 students, so you would take that total cost and divide it up into 150 ways. That gives you the cost per student. Remember, C represents the cost per student. So one of those equations is what we're looking for, either that one or that one. They are a fact family. They are both the same thing, just solved for different variables. Number 4, let's go ahead and sketch a graph showing how the cost per student changes as the number of students increase. So if you haven't done this yet, pause the video and do this in your notes. Okay, so here we have our graph with our table. This relationship should look familiar. So when we sketch the graph showing how the cost per student changes, this bottom portion here, this is the number of students. And I went by 25 because you notice it goes 25, 25, a change of 25. And then I went by 5s because my highest was 30, my lowest was 3. I can easily get that on my graph, and this is the cost per student. So make sure we're labeling our axes as well. And you notice as the number of students increases, so as this increases, the cost per student actually decreases. Okay, so that's what our graph looks like. And if we were to sketch a line of best fit, it would look something like this. And now we're going to answer some questions about this type of data, looking at other numbers. And we know that this is not linear. We've already looked at ones like this. We know that these are inversely related. So these two variables, the number of students and the cost per student, are inversely related. Right? There's a huge change at the beginning, right? Between, for example, 25 people and 50 people, that's a huge change. But then when 25 more come, that's a smaller change. 25 more, that's even smaller. And as more and more people come, the change in cost per student gets less and less. Go ahead and try B on your own. You're finding the change in cost per student as the number increases. So from 10 to 20, right? For example, when it's $10, the cost per student, remember you would take, to find this, like we did up here, you would take 750 divided by that number of students. So it'd be 750 divided by 10, and that's where we would get that it's 75. And then divided by 20, that is 3750. And then you're finding the change in between those. So when it changes from 75 to 3750, what does that change? Okay, go ahead and try letter B, 1, 2, and 3 on your own, and then come back to the video. Okay, so let's go ahead and take a look at these. On 1A, we already did this. It goes from 75 to 3750, right? So that's a change in 10 students. That's important to understand. This is a change in 10 students. But in this case, it doubles. It goes from 10 to 20. So it would make sense that the cost would be half of, the cost per student would be half of what it was when it was 10. Now it's 20. So the change is going to be 3750. Which is half of 75. Now, you notice over here on part B, we still have a change of 10 students. All right, nothing has changed, only now there's more students. You start with 100 and you add 10. You notice it goes from 750 to 682, and that's only a change of 68 cents. Very different from 10 to 20, where it's a change of 3750. And then lastly, from 200 to 210, goes from 375 to 357, and that's a change of 18 cents. Again, you're adding the same amount of students, you're adding 10, but the change per student is much smaller. Then on part 2, it asks, is it linear? Is this change in students, the cost per student, linear? And the answer is no. It's not linear because the change, even though you're changing 10 students, it does not have the same effect throughout. If it were linear, then the change from 200 to 210 will be the same as the change from 100 to 110 would be the same from 10 to 20, but it's not. And so number 3, do equal increases in numbers of students cause equal decreases? No, that's similar to number 2, how we decided to answer that one, but no. As there are more students, the change in cost per student is getting smaller and smaller and smaller. Okay, go ahead and answer part C. Do 1A, B, and C, and that'll help you do 2 and 3 on part C. Pause the video, do those on your own, and then come back. Okay, so some of that was being recorded, but that's okay. So how in part C, how will doubling the number? Number 1, when you go from 20 to 40, that goes from 3750 to 1875. That change is 1875. Okay, so you double from 20 to 40. Then what happens if you double from 40 to 80? Look at the change. It goes from 1875 to 938. That also, or it doesn't double, it actually halves. It doubles if you go from 40 to 20, right? So it halves. And so it's a change of 938. And on the last one, it 2 halves. It's a change of 469. Because also in the last one, it doubles from 80 to 160. Now, that answers in part 2. It says describe any patterns you see in your answers to part 1. Well, it halves them. So if you have twice the amount of students coming, the cost for you as an individual student will be cut in half. And then part 3 says, how does that equation help us answer why this happens? And here's what's going on. Right, here's our equation. This is the cost per student right here. Cost per student. This is the total cost. And N is how many students are coming. Well, listen, if N is, let's say arbitrarily, N is 4. So cost is equal to 750 over 4. And then we double that. Now it's 4 times 2, which is essentially halving the 750. It's like taking that, dividing it by 2 and 4. So it halves what 4 was. Okay? So take these things and put them into your own words. Don't just copy what I put on the screen. Put them into your own words so that they make sense to you when you come back to study them later. And then for the last one, let's go ahead and take a look at D. Science teachers decide to charge $5 per student for the field trip. They will use any extra money to buy science equipment for the school. Go ahead and try this one on your own. Answer those questions on number 2. Then I want you to sketch a graph of that relationship and then answer questions about that graph. So do this, and I will try to remember to pause the video this time and then come back and see how you did. Okay, on the first one, write an equation for the amount A the teachers will collect if N students go on the trip. So if it's $5 per student, that gives us the change. That's the cost per student. Up here, we did not have the cost per student, right? That's what we were trying to figure out if n number of students go. In this case, we have the cost per student. So it's a little bit different because of the constant we are given. In this case, the rate is the constant, okay? So our equation looks something like this, where n is the number of students that can go. Number two, if we sketch a graph, again, you have to think about what your axes are going to be. The bottom right here, so the amount collected is your A, and this is the number of students. That is your independent. That is independent to the amount that's going to be collected. And so when we sketch it here, we see the red dots are those points on the graph. If 10 students go, it's going to be $50 collected. 20 students go, it's going to be $100. And I just multiply each one of those 10 times 5, 20 times 5, and that's where those values are coming from. And then part C, does this graph show a linear relationship or an inverse relationship? Look, it's a straight line. So it shows a linear relationship. We've seen this in the past. So we're using the same equation, but instead of not knowing what the cost per student is, we know what the cost per student is, and it shows a linear relationship versus an inverse relationship. So knowing what the constant is and what variable the constant is super important in whether it's going to be an inverse or whether it's going to be a linear relationship. That's it for this section, planning a field trip, looking more into inverse relationships and what they look like and how to identify them graphically.